Okay, so in this video, we're going to be discussing trig special angles and an easy way to remember them. So a lot of the videos will sell you these ideas like the five fingers or the hand rule, or they'll draw you triangles. And yes, these do work, and other people would just prefer to go ahead and learn them. But there's one particular way that I found is best, and I'll go through that with you now. So the best way, in my opinion, is to write down your trig ratios on the side here. So we have sine, cos, and tan. Okay. Now, our special angles, we have 30 degrees, we have 45 degrees, and we have 60 degrees. Now, the simple thing to do is for all the sine and cos angles for 30, 45, and 60, we're just going to write over 2. That's all we're going to do. Okay, now we'll go in the sine angles for 30, 45, and 60, we'll write 1, 2, 3. Now we'll square root the numerator. So square root of 1 is just 1, so we leave that. Square root of 2, square root of 3. Now for cos, we do this in reverse. So it's 1, 2, 3, and we do the same rule. So root 1 is just 1, root 2, root 3. Now we already know that tan is equal to sine over cos for whatever angle. We'll just say x. But now in this case, sine of 30 over cos of 30 should give you tan of 30. So this angle right here, this ratio, should be 1 over 2 divided by root 3 over 2. And that is equal to 1 over 2 times by 2 over root 3. Now the 2's cancel, and we get 1 over root 3. Now we'll rationalize the denominator, and we'll times this by root 3 over root 3, which is equal to root 3 over 3. So here we have root 3 over 3. Now, for 45 degrees, root 2 over 2 divided by root 2 over 2, it's the same thing, so it's just 1. Now for 60 degrees, we have root 3 over 2 divided by 1 over 2, and you'll notice that if we were to divide that, those 2's would cancel, and then we'd just be left with root 3 divided by 1, which is just root 3. So you see there, that's the simplest way to remember them. Now you might also ask, what about 0 degrees, 90 degrees, 180, 270, 360, and anything beyond that? Obviously we can just use reduction, and that's a topic for another video. But I'll go over now quickly a way to remember the 0, 90, 180, and 270, and 360 is going to be the same as 0, so we won't really talk about that. But to do those, the easiest way that I found is to just remember the general shape of the graphs. And at all these significant points on the graphs, we will see, which is at 0, 90, 180, 270, we see all these significant points, and we can then go and look and see what the relevant trig graph corresponds to. So, if this is our sine graph, this is going to look something like this. Okay, if this is our cos graph, it's going to look something like this. And if this is our tan graph, it'll look something like this. We'll have an asymptote there, and I'll have another asymptote there, and we'll do that. Now, let's first refer to the sine graph. So basically over here we have 0, over here we have 180, these are all degrees by the way, and over here we have 360 degrees. Now, this is 90, and this is 270. Now, from this it's really easy to see that at 0, 180, and 360, we have sine of that angle equal to 0. So these angles here, not that one, sorry, it's this one, 0, 180, and 360. So this angle, theta, from the blue. We also know that the sine at these angles that I'm going to put in pink, the 90 degrees, well, basically just sine of 90, I can just write it, is going to be 1, and sine of 270 is going to be equal to negative 1. So those are really simple ways to remember that. We can do the same for the cost graph quickly, so let's just do it. So we have 0, we have here is 180, here is 360, then we have 270 degrees, and we have 90 degrees. Now we know cos of 0 is equal to 1, cos of 90 is equal to 0, cos of 180 is equal to negative 1, cos of 270 is equal to 0, and cos of 360 is equal to 1. Now if we go and look at our tan graph, we'll do the same quickly again. So we'll see that this is 0, this is 90, this is 180, 270, and 360. So your tan graph has a period of 180 degrees, unlike the sine and your cos graphs, which have periods of 360 degrees. So basically, the tan graph repeats itself every 180 degrees, and every 90 degrees, well, every 180 degrees. So if you take 90 degrees and you keep adding 180k, and k is an integer, you have your asymptotes, which is here and this line. Okay, so that's where your tan graph is not defined. But at tan 0, and tan of 180, and tan of 360, they're all equal to 0. So that's really a simple way to remember your trig special angles. There's really no need to go ahead and learn all these complicated ways. It's really the simplest, just to have a broad understanding of how it works. So then I'd go and recommend that you go and learn the trig angles with a 30 degrees and 60 degree, 90 degree angle, that triangle, as well as a triangle that has 245 degrees. It's an isosceles. It's an isosceles right angle triangle with the 245s and the 90. And you can learn those, and I'll do them after this quickly, but for understanding. But really, to remember them, it's fastest just to use this method over here that I've explained here, especially when you're in a test environment. But I'll go ahead and explain the other methods of it right now. Okay, so we have an isosceles right angle triangle. So this doesn't really look isosceles, so let's just bring that in a bit. So basically what we're saying is those sides are equal, and that is 90 degrees. Now hypothetically, for the purpose of this, in its simplified form, because remember we're going to be using all triangles like that are similar to each other. So we'll simplify this to a form where it's easy to deduce your trig ratios. So this is going to be 45 degrees. And that's going to be 45 degrees. So what I'm saying is that we're going to use side lengths that are simple. So we'll have 1, 1, and we know from the Pythagorean theorem that this is going to be root 2. Okay, so now if we use the acronym SOHCAHTOA, which I'm sure you've come across, and if you haven't, I'll explain it quickly. So this basically says sine is equal to the opposite side divided by the hypotenuse. Cos is equal to the adjacent side divided by the hypotenuse. And tan is equal to the opposite side divided by the adjacent side. Okay, so if we say sine of 45 degrees, what we have is 1, which is the opposite side of 45 degrees, divided by root 2, okay? So we have 1 over root 2. Go ahead and rationalize the denominator, and we get root 2 over 2. And if you refer to the diagram above, it's exactly the same thing. And we go ahead and we do that for cos and tan, and we'll find that we get the same thing again as what is shown here for the 45 degrees. So now I'll go ahead and show you a triangle for 30 degrees, and I'll prove one of them, and you can go ahead and prove the rest. So for the next one, I'll perhaps, I don't know, I'll see. But I think I'll do the tan of 30 degrees. So if we look at this, we have this triangle roughly correct with the 90 degrees there. That's 30 degrees, and that's 60 degrees. So now this side here is going to be, so this side here will be 1, that side there will be 2, and this will be roots of 3. Then, if we do, I said I was going to do tan of 30, okay. So tan of 30 is opposite of adjacent. So we have tan of 30 degrees is equal to 1, the opposite, over the adjacent, root 3. Rationalize the denominator, and we get root 3 over 3. And that's the same thing that we got here. So really these trig special angles can be done in this way as well. You can validate what I've said with this triangle for these angles here as well, if you'd like. But really it's all quite simple to understand, and if you use the methods that I've shown you in this video, you shouldn't go wrong. And if you really come unstuck, then by all means go ahead and use the triangles, but you shouldn't really need to do that. I suggest you just commit it to memory. These triangles I actually found were more difficult to remember than the methods I showed you earlier. But anyways, that's the video, so please like and subscribe, and I'll see you in the next one.